Example 1.8. A light travels from air into an optical fiber with an index of refraction of 1.44. So it said that we have two types of medium. Air, which is 1.0. So this one you need to remember because the basic things or the lowest refractive index is air ataupun vacuum. So it's equal to 1.0. While for the optical fiber, equal to 1.44. So which one is N1, which one is N2? If the incident ray come from the air, so air will be N1, while optical fiber will be N2. So compare the two value of refractive index. N1 is less dense than N2. So what happens if the incident ray travels from less dense into a denser medium? The answer is the refracted ray will bend towards the normal line. Okay, so this is the answer for question A. For question B, if the angle of incident ray is 22 degrees, what is the angle of refraction inside the fiber? So we can use the Snell's law equation. Sin I over sin R equal to N2 over N1. So we can substitute the value. Sin 22 degrees divided with sin R equal to N2, which is 1.44, divided with N1, 1.0. So the value of R is equal to 15.08 degrees. We can see that the angle of refraction is less than angle of incident. Thus, this proves that the refracted ray will bend towards the normal line. So let us sketch the path of light as it changes the media, or we call as the ray diagram. We can label the angle of incidence here, which is 22 degrees. And once it enters the optical fiber, the angle of refraction is 15.08. Next question, example 1.9, we have a cylinder glass rod with refractive index n equal to 1.52 is placed in air. So one end has shape of a hemisphere. Hemisphere is separuh bulatan. So this is the hemisphere shape. The radius of the hemisphere is 1.5 centimeter. So radius is the distance of point C from the surface. If an object is placed 50 cm from the hemisphere as shown in the figure above, find the image distance V. So this is the object. So the object is placed 50 cm from the surface. Since this glass rod has been labeled as n equal to 1.52, this medium will be the air, which is 1.0. To solve for the image distance, we can apply the spherical refracting surface equation, which is n1 over u plus n2 over v equal to, in bracket, n2 minus n1 divided with r. But before we substitute the values into the equation, please check the sign first. For n1 and n2, there will be no sign. Okay, so you can just substitute, but for u, v and r, we need to check the sign. Okay, so let's start with n1. Which one is n1, which one is n2? So look at where is the incident ray. So the incident ray will come from the object, so this medium will be n1 and this one will be n2. So n1 is 1.0 divided with u. U is the distance of object. So object is placed in front of the spherical mirror, so it will be positive, real object, positive 50 centimeter, plus with n2, which is 1.52 and V equal to 1.52 minus 1.0 divide with R. Now let's check whether R is positive or negative. How to check? Look at point C. If point C is situated in a denser medium, so it will be positive. If point C is situated in a less dense medium, it will be negative. So from this diagram, point C is situated in a medium of 1.52, which is greater than 1.0. So point C is situated in a denser medium. R will be positive 1.5 centimeter. From this equation, you will get the answer for image distance V, which is positive 4.65 centimeter. So based on the sign convention table, positive V shows that the image is real and form opposite side with the object. .65 centimeter shows the distance of the image formed. So now let's try to label where is the image formed in this figure. So the image is real and form opposite side with the object. So image will form at this side. So let's say this is the image form. It form opposite side with the object with the distance of 4.65 centimeter. Next example, 1.10. Based on figure 1.14, calculate the image distance for a point object O, which is situated at a distance of 8 cm from the spherical surface in a higher refractive index medium. Given that the radius of curvature is R equal to 10 cm, N1 refractive index equal to 1.5 and N2 equal to 1.0. So from this figure, the object is 8 cm from the surface. N1 is 1.5, N2 is 1.0. So incident ray will come from this object. So this one will be N1. And N1 is greater than N2. So how do we know where is the image distance? Let's use the spherical refracting surface equation. N1 over U plus N2 over V equal to N2 minus N1 divided with R. So N1 is equal to 1.5, U is equal to positive 8 cm because the object is placed in front of this spherical surface, plus with N2 1.0, V equal to 1.0 minus 1.5 divided with R. Now let's check whether R is positive or negative. So from this figure, point C is situated in the less dense medium. So R will be negative 10 centimeter. From this equation, we will get V equal to negative 7.27 centimeter. What does it mean by negative? Negative for V shows that the image is virtual and form same side with object with a distance of 7.27 cm from the surface. So object is here, image will form here also, same side, but with distance 7.27. So let's say image is here, 7.27 centimeter. That's it. So from this video, you have learned about the refraction light, law of refraction, refraction at a plane surface. We have the equation of Snell's law, sin I over sin R equal to N2 over N1. We also have the refraction at a spherical surface, and we have this equation, spherical refracting surface equation, N1 over U plus N2 over V equal to N2 minus N1 divided with R. Don't forget forget about the sign convention.